Okay, section 5.3, tangent functions. This is where we're going to graph lines of tan. So, in tan, you need to remember these following points, okay? So, they don't have an amp in tan, because tan graphs, I'll just give you a rough look at what one looks like. Oops, my thing's a little off, but they would look like this. Okay, that's what a tan graph looks like, roughly. So there's no amplitude because they go up and down for an extended amount of time. We don't know how far. Okay, the period length for amp is pi. So you could say pi over b. And the graph has no max and min because there's no amplitude again. And then you would say the range is all real numbers, so all values including y, because they just keep going and going and going. Then we have a vertical asymptote at a half. So you notice how I just drew two tan pictures halfway through at pi over 2. That's a vertical asymptote. So your picture actually is a tan wave, and then it jumps over the line, and it's a tan wave again. Okay. And then it says the y-intercept is 0. And I added to mine. You might want to add to yours. No amplitude. So if I ever ask you, what's the amp of this tan equation, even if there's a number in front, still no amplitude. Okay. Okay, so I'm going to try to draw this one. My pen's a little bit off, but so if I was drawing just this tan graph and it says doing to all the way to 2 pi and to negative 2 pi, it just means keep repeating, right? So we'll have 4 ticks. This is halfway. Okay, and we said that there's an amplitude, or not an amplitude, an asymptote at a half. Okay, so our picture is going to be at the origin, and then it's going to be at our period length, which is pi. Okay, and then all we... What's that? No. In cosine sine ones, it's 2 pi. In tan ones, it's pi. Unless it's pi over b, whatever that is. Okay. And then all you do is, I kind of make a movement here at 1 over, 1 and 1, and 1 and 1, just to keep my shape. Okay, so I go 1 and 1, 1 and... No. Well, hold on, where's my shape? And then I draw it like this. And then this one, sorry, 1 and 1. Do I have an eraser? Oh. Okay, so I'm not really worried. Like, these should be curving somewhat at like -1 there, or at 1, but I'm not too worried about that particular shape. And then if you just had to do... Oh, sorry, I drew this on the wrong dot. I messed my dots up. We have a tick here. Our picture should be here like that. Okay, and then it would just keep repeating. So if it said you had to do it for 2 pi, 1, 2, 3, 4, this would be 2 pi. Halfway in between is this. And then you just draw another one. Okay, so tan graphs aren't that complicated because they don't have a lot to them. Okay, so example 2 says a small plane is flying at a constant altitude of 6,000 meters directly toward an observer. So we have somebody here, and the altitude is 6,000 meters. And it says, assume that the ground is flat in the region close to the observer. Determine the relation between the horizontal distance. So this is the horizontal distance in meters from the observer to the plane. So we'll say here's the plane. What looks like a fish. And so this forms kind of a right triangle. Okay, so if we want to determine the relationship between the horizontal distance and the plane, then remember, we're going to be using tan, whatever the angle would be, and opposite and adjacent. That's what tan is. So if we're at the person here, opposite is D, and adjacent is 6,000. So we can't solve this because we don't know the angle or anything. They just want us to write the relation. And then it says sketch the graph of the function. So if we were drawing what this would look like, it's just a tan equation. And we would say 6,000 is basically our 1 that we were talking about, or negative 6,000. Okay, and then we'd make our 4 movements. And our picture would kind of curve here and somewhat curve there. You have a symptote, and then again it curves and curves. Oh, it disappeared. Sorry, our picture disappeared. We'll go 6,000, 6,000. And we had our picture like this, kind of curving at 6,000. And then like this. Okay, and then C says, where are asymptotes located? Well, I drew it. It's halfway through our period. So we could say it's at 90 degrees or it's at half pi, or pi over 2, right? So pi over 2 or 90 degrees, because those are the same thing. And then explain what happens when the angle is equal to 0. So I think they're talking about when the angle is equal to 0, the plane is not to the, or it says they show when the plane is on the ground to the right or the left of the observer, which is impossible. Oh, that's for C. Where is the asymptote located and what do they represent? So they're just saying this is where the plane's to the right or the left, but on the ground, so it can't be on the ground because it's flying. Otherwise, it would crash into the guy standing there. So that's why it's asymptote. It jumps over that point. Okay, and then D says explain what happens when the angle is equal to 0. The plane should be straight above the person at an angle of 0. That's why it's at 0. Okay.